There are total 7 topics that you must learn in order to become a certified Kubernetes application developer. What these 7 topics are, and the percentage-wise exam topic, including what these topics include, who all should prepare for this certified Kubernetes application developer, including how to prepare for this exam. I'm going to cover all this in today's episode. Welcome to another episode of weekly video series with me, Atul Kumar from team CKAD Academy on Docker and Kubernetes, where we tell you everything right from beginners to an advance in both Docker, Kubernetes, including cloud native. Now, before we look at all these 7 things that you must be learning, let's first look at why to learn Kubernetes, especially if you are a beginner or because someone suggested that you should do Kubernetes, why it's important. So if you look at the evolution of a development and deployment, the development process has gone from waterfall model to agile to DevOps. Similarly, the application architecture has gone from monolithic to n-tier to the microservices. And because of these microservices, you deploy these microservices on containers. And to manage hundreds and thousands of containers, you have container orchestration tool like Kubernetes. Now, I said the applications have gone from monolithic to microservices. So let's quickly look at what is monolithic versus microservices. In monolithic, all the business logic of different logic is bundled into the single application. And the challenge because of that is any modifications, bug fixes, updates become very time consuming. Whereas with microservices, you deploy each functionality in its own service so that any changes or update, you only need to look at that particular web service or integrations with respect to that particular web service. So the speed at which you make changes becomes quite easy. Now with microservices, now if you deploy that microservices on a virtual machine or a physical machine, the resources are underutilized because these microservices are very small, tiny ones. So in order to fully optimize your resources, use containers or container platform like Docker. So each of this microservice runs on its own container. These containers take very small time to boot up. They take very less disk space and very small memory. So the resource utilization for containers are very small. Now, typically you don't have just 1 or 2 container hosts, you have 50, 60 container hosts. And on each of these hosts, you run 15 to 20 containers easily. So in any medium or bigger size company, you are running or managing thousands of containers across different environments. And this is where the container orchestration tool like Kubernetes comes handy. And because of all these reasons, you see and come across multiple jobs related to Kubernetes. So if you see, this is just an example of jobs in Kubernetes as a developer from United States, UK, or India. So now you understand why everyone is learning or moving towards Kubernetes. Now let's look at who all should be doing this Kubernetes application developer. So if you are a developer, whether you're developing in Java, .NET, JavaScript, Python, Go, Ruby, or you are developing microservices in using any of these frameworks, or you are an architect, whether it's a technical architect, solution architect, or application or enterprise architect, or you are working onto QA, testing, or automation engineer, these are the ideal candidates for Kubernetes application development. Because when someone is developing, you also need someone to design these applications and then also the tester to test these applications. Now, with these 2 things, let's look at the exam topics. So the first thing you should do is you should go to Cloud Native Computing Foundation, CNCF. So CNCF provides the certified Kubernetes application developer. Now I'm going to share these 2 URLs on the show notes, which will be available on k2academy.com/Kubernetes dev 11. So look at that URL, and also there'll be frequently asked questions section that will cover most of your questions. Now let's look at these exam-wise topics. So these are the 7 topics that you should be learning. So the first topic is 13% core concept, and this is where you cover the basic APIs that are available from Kubernetes. You should also be knowing and learning architecture, configuration, and the basic pods. What is a pod? I'll tell you in a minute. Then another one is 18% for configuration. What all things you should be learning in configuration? We'll cover that in a minute. Then another one is 10%, which is multi-container pod, which means multiple containers running inside a pod. Again, I'll cover in a minute what this pod means if you're beginner or if you're new to Kubernetes. Then 18% is observability. And this is where you should be knowing about liveness or readiness. What is the difference between these two? Logging, auditing, and debugging. Then the highest percentage is pod design. This is where you'll be looking at labels, annotation, deployments, how to do rolling updates, rollback, and your jobs and cron jobs. Then sixth topic is about networking and services, 13%. And finally is your storage, which is state persistence. Now, towards the end, I'm going to also give you a access to a free approximately 90-minute masterclass where we talk everything about certified Kubernetes application development, where I'm going to bring an Kubernetes expert, where we go a little bit deep into these topics. So that's something towards end. So now let's go into a little bit deep into these 7 topics. So the first topic is core concept, and this is where you should make yourself familiar with the architecture. So as you probably know, Kubernetes consists of a master node, and within that master node, what all components are there. Then there are multiple worker nodes, and worker node is where your applications run. And this is where your container runtime, like container D will be there, and your pods, which is where your applications run, though your pods will be there. There'll be another component called kubelet and kubeproxy that will be part of each worker node. If you're running your Kubernetes on cloud, you have something called managed Kubernetes. And in that managed Kubernetes, you have an additional component, which is cloud controller. The primary job of cloud controller is to provide the underlying storage, networking, or other resources that your Kubernetes require. Now, if you want to go a little bit deep into this architecture, I've done another episode which is available at kuberneteacademy.com/Kubernetes 12, where we go a little bit deep on these Kubernetes concepts, including architecture and component. Now, with that, you should also be familiar with the basic APIs that are part of Kubernetes and commonly used Kubernetes commands like kubeadm to install and configure cluster and kubectl to manage your Kubernetes cluster. Now, you should also be familiar with what is the difference between virtual machine, container, and pod. Now, in Kubernetes, the collection of one or more containers is called pod, and pod is where your application gets deployed. Now, if you're still unsure about what is difference between a virtual machine and a container or Docker, then have a look at k2nacademy.com/Docker12. I've done a previous episode talking about difference between virtual machine and container or Docker. As I said just now, you should also be familiar with pod. Pod is the smallest deployable unit inside Kubernetes on which your application runs. So inside pod, you can have one container and normally you'll be deploying one container, but you can also have in certain scenarios multiple containers as well. Now the best practice is to have one container per pod, but in certain scenarios you might have more than one container inside a pod. Now most of the deployment you do in Kubernetes using something called as YAML file, and this is one representation of YAML file. And in order to deploy a pod, I can create a YAML file like that, which I'm saying I'm deploying a pod. That pod contains a container of type Nginx, which is a web server, and that is listening on port number 80. So this is an example of pod. As I said, best practice is you have one container per pod. So that's basic concepts, architecture, and component of Kubernetes. Then the second topic for certified Kubernetes application developer is a multi-container pod design. So as I said in the previous section, in certain scenarios, you might need multiple containers inside a pod. For example, you're running a web and a file sync that needs a shared volume or shared storage. In those scenarios, you will have two containers part of the same pod sharing the same storage. So in order for you should understand the design patterns, there are different type of design pattern like sidecar, adapters, or ambassador. In what scenario you will need them and which one to use and what pattern to use in what scenario, you should be knowing that. Then the third topic is about configuration, and in configuration you should be familiar with config map. So what config map do is, let's suppose you have a specific configuration which is environment specific. So you have one configuration for development environment, second configuration for prod environment, another for test environment. So instead of keeping that configuration parameters inside an image for your pod. You put that configuration data inside a config map. And then when you're defining the pod template, different depending on different places, you can then feed this config map to create at the time of provisioning of pod. So each of your test dev prod environment will have separate config map, but rest of the things like your image will remain same. Then you should also be familiar with role-based access control and service account. So things like who did what. So there are users, there are groups, and there are service accounts in Kubernetes. And then these accounts will have access to some of these resources. And these access to the resources are granted via the role, where you can allow some access or you disallow some access to other resources. And that is done using a role binding. So make sure you're familiar with RBAC and service accounts in Kubernetes. Now the config map that I mentioned in the previous section was for the configuration, which is for non-sensitive data. But if you have sensitive information like your username passwords, the passwords you'll be keeping them into secret. Now secret will be stored in something called as etcd, which is a database on the master node on Kubernetes. You store your passwords there, and when a pod needs your passwords, it connects to the secret and get that details or sensitive information from there. So make sure you're familiar with secrets. How do your pods or application running on pod can use those secrets? So that's topic 3, which is configuration. Now let's look at topic 4, which is observability, including logging, auditing, and debugging. Now, what happens is when your application starts on a pod, first it goes into the status called liveness, which means it's live. But then till the entire all the parts of the application come up properly, it will not be ready. So in order for client to access this application, it should be both live as well as ready. So as a part of you as a developer, make sure you're familiar with the concept of probe, liveness probe, as well as readiness probe. And how do you use that in your application? Also, you should be familiar with logging, and there are different type of logging. You can configure logging at the node level. You can define a specific agent on the node or a host on which your pods run, or you can have a cluster level logging. You can define for entire Kubernetes cluster, or you can expose your logs from application directly to third party from any app. So the logging is very important. Now, similarly, that Kubernetes application, it generates a lot of events. So you can use this event, and if you want to go a little bit more advanced, you can configure these audit events to go some external source. Now, again, this is not from the certification, but you should be familiar with auditing or enable auditing within your application for Kubernetes. So that's topic 4, which is observability, logging, and auditing and debugging. Then topic 5th is about pod design, and within pod design, you should know deployments, rolling updates, rollback, and your cron jobs. Now, Kubernetes is a declarative application where you tell it that you want 3 nodes or 4 nodes or these many applications, and Kubernetes will go and do it for you. And so this task is done using something called as deployments. Now, deployment will take care of your scalability. They will take care of your self-healing, rolling update, and rollbacks. So you can deploy the pod without deployment or with deployment. It's always recommended to deploy your pods using deployment so that you can use features like self-healing, scalability, rolling update, or rollbacks. Now, make sure you're familiar with rolling update and you know how to configure these rolling updates. So there is a concept of replica set. So if you are ready to create a new version of your application, you will create another replica set with a new version of your application, and you tell your Kubernetes cluster to retire the previous version and use the new version. It will do it for you. So what you see on left hand side was the old version. It'll remove that these pods from the replica set, and then it'll configure the new pods. And how long it both the version can run or should run, these are all configurable options. Now, for some reason, if you identified that you want to roll back and you want to go back to the previous version, you simply tell it to your cluster saying you want to roll back, and it will remove the pods, new version of pods with a new application from this replica set, and then point or redeploy your application with the older version on the older replica set. So that's rollback. Make sure you're familiar with rolling update, rollback, deployments in Kubernetes. And then another topic is your cron jobs and jobs. So you might have some scheduled tasks that must run on a specific time, and this is where your jobs and cron jobs will come handy. So these are all the things that you should be knowing from topic 5. Then the sixth topic you should be knowing is about service and networking. So in your cluster, all the pods that are part of one cluster can talk to each other without any additional configuration. But if you have a client that is coming from outside the cluster, then that client will not be able to talk to these pods or applications running on these pods. And this is where you need something called as service. So service uses a concept of label where you create a label within a service and say two labels, for example, environment is equal to prod and version is equal to v1. So any pod that will have these two labels where the service will forward then request to these any of these available pods that will have the same label. Now the advantage of having the label is that first the external clients can connect to this service, and then service will in turn forward these requests to pods. But the bigger advantage is that when pods die, or if anything happens to these pods, a pod will get a new IP when the pod restarts, and the service will automatically map to this new IP based on this label. So end user will never have to remember or do any configuration changes. Client will always connect to the service IP, which is always static. And the service IP will then in turn forward to these pods or applications running on these pods. So make sure you understand how to create service and configure them to forward requests to the pods. So now there are four different type of services that are available inside Kubernetes. Make sure you're familiar with all those four type of services. Then you also have something called as ingress controller that can also drive traffic or control traffic between your end users and to the Kubernetes cluster. And the final piece from a networking point of view from developers, you should be familiar with networking policy and you should be using the network policies. So the network policy will dictate ingress, which means incoming request who all can connect to your cluster or applications running on that cluster. And same as egress, what all applications can go out and connect and what all you can control through network policies in the Kubernetes cluster. So that's from the topic 6, which is networking and services. Now the topic 7th and the final topic is storage or state persistent. Now typically initially when Kubernetes was built or containers were built, these were built for stateless application and they are still the major chunk for the stateless application. But as Kubernetes is maturing, we notice a lot of persistent type of applications that needs to maintain the data or state or the storage. And this is where you have the storage volumes come handy. So you can mount a directory, you can mount an external different type of storage, be it a block storage, object storage, NFS or shared file system, or SMB, different type of store file systems you can mount. And these can be mounted to a pod using something called as persistent volume. And then this persistent volume, you also have something called persistent volume claim. So you need two things. You need a volume and you need a claim. So pod will have access to the claim and then claim will be tied against a persistent volume. And this is how your application or pod will get access to the storage and your application running on that pod can then use that storage volume. So make sure you're familiar with PVC, which is a persistent volume claim, and then PV, which is a persistent volume. So here's an example where you taking a 50 GB of volume from, for example, AWS storage. Then I need to have some storage plugin in my Kubernetes, depending on the type of storage I have. Then I'm creating a volume and then I'm taking a claim and then giving it to my pod. So then my application can then start using this volume through this claim. So make sure you're familiar with PV, persistent volume, and persistent volume claim. So these are the 7 topics that you should be familiar. Core concepts, then configuration, then you have multi-container pod, especially the pod design pattern, 3 different type of design pattern, observability, then pod design in terms of deployment, rolling forward, rollbacks, cron jobs and jobs, then services and networking, that's networking part, and then storage that includes the persistency. Now, if you look the exam is for 2 hours. It's purely hands-on lab or lab-based exam, the fees is $300 and the passing score is 66% or higher in order to get this certificate. Now you get one retake, which means for some unlikely reason, if you can't clear the exam on first attempt, you get one more attempt to clear this. And the certification is valid for 3 years. Now I have a step-by-step comprehensive training program on Docker and certified Kubernetes application developer. Now for this Kubernetes application developer certification, you don't need to do anything for Docker, but having a Docker knowledge is important. And hence is this step-by-step comprehensive training program. We also include Docker as well as Kubernetes. The program consists of 18 modules, 80 plus lessons, 35 labs, and this is important for you because the exam is the lab based, which means you're going to do, there's no multiple choice questions. You are going to actually do the labs, and hence I'm going to recommend these 35 labs that you must perform. The most important part in the program is the on-job support. So we provide 1 year on-job support. So what all hands-on lab that you must do and we recommend in the program, these are the 11 labs that we say for Docker, right from how to install Docker, how do you configure images, create containers, create networking and different type of networking. You have a host networking and custom bridge networking. You also need the Docker host itself network. Then the different type of storage, which is host path or Docker volumes. And this is all Docker. Then how you enable debugging, which is for DNS logging storage. How do you create your images using Docker file, and then how do you work with the application stack running on that Docker. Now, once you do understand Docker, you can do the same concept for any other container runtime you're using, whether it's Containerd or Rocket or anything else you're using. So make sure that you make yourself familiar with first with Docker, and then 24 labs we recommend for Kubernetes. If you really want to clear the certification, and not just clear the certification, but do a good job for a customer end and get a good higher paid job, these 24 labs for Kubernetes alone are important. So first is you should be familiar with installing and creating a minimum 3 node cluster with one master and 2 worker nodes. You should also be familiar with creating multiple master nodes so that you have high availability for master node components. So how do you install using KubeADM, and also how do you bootstrap your cluster on cloud, be it AWS cloud, which is EKS, Elastic Kubernetes Services, or on Azure, which is Azure Kubernetes Service, AKS, or Google Kubernetes Engine, GKE. Then you should be familiar with networking. We discussed about services and networking. In that I said there are different type of services you should be familiar with. So especially you should be doing cluster IP and node pod. These are the two common services used extensively. Then in deployment, make sure you deploy an application using deployment and replica set. So you should be actually creating a YAML file and deploying your application inside the Kubernetes cluster. Then make sure you also do a lab for upgrading or updating a new version of the application, or roll back that application using deployments and replica set. Then the auto scaling, which means if a load on your node increases, the pod will automatically scale up or new pods will spin off. So how do you configure automatic scaling of applications? Do a lab for that. Another lab you should be doing is about storage. So persistent volume or PVC or claims that we discussed. Then certain applications require your application to run on a specific node or host. So how do you map a pod saying that it always runs on that specific node? So pod assignment to a specific node. We call node affinity, or how do you make sure that a pod will never go to a particular node? So you might have two different applications which they should always run on the same node, or they should never run on the same node. So these two labs you should be performing. Then you should also be doing the pod scheduling, and how do you limit the resources? So you don't want your application to use unlimited memory or CPU or storage. So how do you put resource quotas and limit your application to not go beyond a particular point? Should do a lab for that as well. Then I discussed and mentioned about probeness or readiness and liveness. So make sure you do labs around liveness and readiness in your practical exercises. Then comes your logging, auditing, debugging, troubleshooting. All these things, how do you enable or audit events? Configure all those using in the application or through the Kubernetes cluster. Now, some of these, like doing on cloud, may not be relevant for your examination, but they're very important when you look for the job related to Kubernetes developer. Then another important lab you should be doing is stateful application. As I was telling that there are more and more use cases coming for stateful application where application needs to see the state or store the data in your application or pod. So deploying a stateful application, configuring ingress controller, making sure that you are configuring security policies as well as network policies on the Kubernetes cluster. And finally, a application end-to-end application on these Kubernetes. So these are the 35 hands-on lab we highly recommend you to do, not just to clear the exam, but also for a higher paid jobs. These are the things that you'll be actually doing in your implementations. And in the program that I mentioned earlier, we cover all these 35 labs in the program, including the theory behind all these concepts. So those who are part of the program, they not only clear the certification or work on the job, we also help you in preparing the CV and preparing you for the job. But the most important point is to give you 1 year on job support. Now, if you're interested to know more about this program or want to go a little bit deep into where I bring another expert, I would like to invite you for a free masterclass where approximately 90-minute class where we go deep into these topics. So I'm going to bring another Kubernetes expert, Mamta, who's going to teach you and give you a different perspective of what I told you earlier today. So if you're interested, register for a free class on Kubernetes Dev 02. Now I'm recording this session on 9th of August 2020, and this episode is going to live on our YouTube channel on 11th, that's Tuesday, a day before this live interactive session that I'm going to run with Mamta. So if you're listening this episode after 12th, we might still be running some sessions or you might see a wait list. So depending on if you see a wait list, enter your name and email address. So when we have these sessions again, we'll let you know. Or if you're running this session regularly, then just enter your name and email address so that you can attend this free masterclass. So the URL is ketonacademy.com/Kubernetes Dev 02. It's absolutely free, and trust me, I always get excellent feedback for Mamta. So that's pretty much from me, Atul, from Team Keton Academy, talking about everything you must know related to Certified Kubernetes Application Developer Certification Program. Now, next week, I'm going to talk about another common question we get in our various free training programs, saying why test team or someone working on QA or automation should learn Kubernetes. Why it's important for test engineers as well to learn Kubernetes. That's coming next week on Tuesday on our dedicated YouTube channel at ketonacademy.com/Docker Kubernetes. I'll see you next week with another episode on Docker and Kubernetes. Till then, take care.